Hi there. Let's see how we can create a laser like this. In this first laser example, we have a source here, a reflection here on this cube, another reflection on this cube, and the laser beam goes far out into the distance. And in this laser example, we have the pointer source here, and without any reflections, it points out far into the distance. We also have this sensor here. When we place it in front of a beam, it completely absorbs the beam and raises a trigger event, as you can see in the console. If I remove the sensor, it raises an untriggered event. And as you can see from the number of events, we only have one per obstruction of the beam and one per release. One thing to note is that this sensor is not dependent on the laser source itself. So if I bring the beam here, I'll clear the console for now. I can navigate it along this beam and then shift it to the other one. As long as it's continuously triggered by a beam, it will not raise a new event. So in this situation, it's actually being struck by two laser beams. But that's not an issue. The sensor could receive as many beams as it wants. If it's always triggering at least one, it will raise no additional events. So this is what we want. So as soon as I then remove it from this one, it will raise this untriggered event. So let's see how we can achieve these laser mechanics. We'll also see how we can have this nice looking beam here with a glowing effect using post-processing. So let's see what the laser script looks like. We have an activated field. We have a line renderer to render the beam. We have a few settings that we can import from this field. We have the source position. We have a far distance, which is if there's no collider in front, how far the ray can reach, basically. So any high number will do fine here. We have a list of bounce positions, and we have the maximum number of bounces to avoid an infinite number of reflections in the case where two reflected surfaces are parallel to each other, for example. We then have a field to keep track of the last sensor that this laser has struck. These are not mandatory. So we grab the component line renderer. We apply the settings. So if I go to this class here, so it's a scriptable object, and we can create it from the project panel with this attribute. We have just the color, the width, and the emission amount that we can adjust within the inspector. And then the apply function here is just gonna do what we expect. So you create a new material and assign these various properties. So if I come back to the laser, we have these settings applied to the beam. Now let's have a look. These are not mandatory. We have the fixed update. So every physics loop, we're going to cast the beam. So check it's not activated. So let's see. We start the source position at the position of the transform, and then this is kind of arbitrary, but it's just that in my case, the laser actually, if we look at the position, it's the center, so I want the beam to start right at the tip of the cube itself. So that's why I add this little offset, but it might be different in your case. Then we initialize this list of bounce positions, and we start it off by putting the source position. And then we cast our first beam, going from the source position and forwards. So let's see what this cast beam looks like. So there we have our cast beam function. It takes an origin and a direction. We return if we go beyond this maximum number of bounces. Otherwise, we create our ray, which goes from the origin in that direction. And we do a ray cast. And if it didn't hit anything, then we can create our point far ahead in the distance, add it to the bounce positions, and essentially return. And otherwise, if it did hit something, then we grab that hit info, that out um, variable here. We grab it and we get the point of collision. We add that to our bounce positions. And then we see if this is a reflective surface. So we just see if we can grab a component of type iLaser reflective. So you could just, I have this interface. You don't have to. This could directly be the class itself with a reflective, so laser reflective class. Doesn't have to be an interface. And then if I have one, that means it's reflective. Then I reflect. And this reflect function is actually, this is going to be a recursive call to the cast beam, because if I look at the reflect function, so it's going to go here, and it's going to actually take the same laser and cast the beam. So this is essentially a recursive call. So we reflect it. How do we do this? Well, the reflect function receives the laser, the incoming ray, and the hit info. And we just use the vector-free function called reflect to reflect in the direction of the incoming ray according to the normal of the hit info. And that creates our outgoing ray, and or rather our outgoing direction. And then we can create a beam from that point, hit info dot point, and in the direction. So this will just reflect the beam. And we cast the beam here, so come back to laser. So we'll do all this function all over again because it's recursive. But if it doesn't reflect, then it will go here. So now let's take a look at the laser sense script. We have a few events going on. These are not very important. These are a bit more important. We have on-triggered and on-untriggered. We have a field is triggered and its property. The getter just returns the field. And in the set, if it's true, we invoke the on-triggered, and if it's false, the on-untriggered, and then we set the field. We have a list of striking lasers. So each laser sensor will have its own list of lasers that is currently striking it. In the awake, we initialize this list. In the start, we set the trigger is triggered to false, which will in turn invoke the on-untriggered. And here we have the function handle laser, which we saw in the laser script. In the cast beam function, we had a few calls to the handle laser function. This is a static function. It takes in a laser, a previous laser sensor, and a current laser sensor. So what happens is the laser, it stores the previous struck laser sensor such that it can then compare the one that it's currently triggering, this could be null, and the one from the previous. And if they're different, we'll go ahead and call this function handle laser, and pass in the laser itself, the previous one, and the current one. And what this will do is just if the previous is not null, it will remove it from, it will remove this laser from this previous sensor. And same with the current, but it will add it. So it will, in some sense, it will update the states of these lists. So if I have a look at remove laser and add laser, we have them down here. So it will do exactly what you'd expect. In the add laser, we take in laser, striking laser, and this is the new one, and we add it onto the list of striking lasers. And then we have this event, but that's not mandatory. And this is important here. If we have a count of 1, or in other words, we went from 0 to 1, then that means we've had our first laser trigger this sensor. So we set is triggered, it's true, and that will fire the event. And then on remove is similar, except if we go down to 0, or from 1 to 0, then we set is triggers to false, which will in turn fire the untriggered event. And that's basically it for the laser sensor. And last but not least, let's see how we can achieve this visual effect for the laser with this nice purple glow. And also, let's see how we can make the settings quite easy to manage. So first, make sure you have post-processing enabled. So make sure you're in the universal render pipeline, that you have a post-process volume, so with a volume component, and the bloom property with some kind of intensity that's set. And also go to your camera and make sure you've enabled post-processing in the settings under rendering. Make sure this is checked, and then you'll be good to go. So let's see how we can use this post-processing to make this glowing effect of the beam. So if I select the laser, I have the line renderer here, and it references a material. This one is responsible for its appearance. If I remove it, you'll see we get this default purple, very boring material. So let's undo that. We're back to our nice glow. So if I have a look at the material, let's open it up. We have a URP simple lit material. The most important settings are actually to have the emission map toggled on. You can see if I toggle it off, there's no bloom. And you also want to set a HDR color, so you want to bump this number up however much you want. And this material is actually generated from a script, which is within the apply function of this scriptable object. So it will create the material on the fly in code. You can see the name of the material, URP and simple lit. And then it will enable this emission toggle here with this line of code. And then we set the color, the width, and the start color. So we have the material color and the start color. And that's how you get a glowing laser. So thanks for watching.